Hello everyone, welcome back to my channel. I'm Ricky. In today's video, we are going to talk about a fascinating battle in modern manufacturing: frictional welding versus laser welding. When we look at the modern machines, from aircraft engines and automobiles to electrical vehicle and industrial equipment, one thing is always critical: how can engineers connect metal parts together strongly, precisely, and reliably? A weak connection can cause a serious problem. For an aircraft engine, a small failure may become a dangerous situation. For an electric vehicle battery pack, an unreliable connection can affect safety and performance. This is why laser welding technology is one of the most important foundations of modern industry. But interesting, engineers have developed two completely different situations. One technology uses mechanical movement and endless pressure. The other used a highly concentrated beam of light. One is friction welding, another is laser welding. They represent two completely different philosophies. The power of the physical force versus the precision of the controlled energy. So today, let's compare these two technologies and find out which one is stronger, which one is faster, which one is more suitable for the future of manufacturing. So let's get started. First, let's talk about the friction welding. Friction welding, just like this. Friction welding is one of the most interesting solid-state welding technologies in the manufacturing world. Unlike the traditional welding methods, friction welding does not match the basis methods. Instead, it creates a connection through friction, heat, and pressure. The work principle is actually quite very simple. Look at this. Imagine two metal components. One component rotates at extremely high speed, while the other component stays stationary. Then a powerful force pushes them together. The friction between these two surfaces generates a large amount of the heat. However, the temperature usually does not reach the melting point of the metal trace. Instead, the metal becomes softer and reaches a plastic state. At this moment, the rotation stops suddenly, and a huge forcing force presses the two parts together. During this process, impurities, the extra layers are squeezing away from this joining area. The atoms from both metals surfaces come extremely close together. Finally, a strong metallic bond is created. This is why friction welding can produce the joints with extremely high strength, because metal doesn't experience a large melting and cooling process, many common welding problems can be reduced. For example, less thermal destruction, lower risk of the cracking. A failure problem caused by challenges in the metal structure, unlike traditional fusion welding, where the metal melts and then solidifies. Friction welding keeps the metal structure more stable. This allows the welder area to maintain excellent mechanical performance. In some applications, the strength of the friction welding joint can even match or exceed the original materials. This makes the friction welding extremely valuable in industries where failure is not an option. However, friction welding also has a limitation. The biggest limitation is the temperature. Friction welding works the best with parts that have the rotational symmetry. For example, shafts, tubes, rods, and another cylindrical components. Complex shafts and large flat structure are much more difficult to process using these methods. Despite this limitation, friction welding remains widely used in industries where mechanical strength is the highest priority. For example, aerospace manufacturers use the friction welded for certain energy components. Automotive companies use it for driver shafts and other high-stress parts. The oil and the gas industry also used it for heavy-duty drilling equipment. In these applications, reliability is more important than appearance. A strong connection that can survive extreme force is the main goal. Now, let's look at another technology that takes a look at completely different approach. Laser welding. Instead of the mechanical force, laser welding uses the central light energy. Laser welding is a fusion welding process. A high-power laser beam is focused onto a small area of the metal surface. Because the energy density is extremely high, the metal quietly absorbs the energy mass and creates a small molten pool. As the laser moves along the welding press, the molten metal cools and the solidifies, create a strongly welded seams. In deeper penetration welding, the laser can create what energy called the keyhole effect. The intense energy creates a smaller vapor channel inside the metal, allowing the laser to penetrate deeper and create a stronger weld. So how does the laser welding compare with the friction welding? This first major difference is the bottom mass. Friction welding creates a solid state connection. The metal remains mostly solid during the process. Laser welding creates a fusion connection. The metal melts and then solidifies. Burstmers can create very strong joints, but they achieve this through completely different physicals. The second difference is flexibility. Friction welding is excellent for simple shafts. It is especially suitable for the components like the shaft, turbo, and rotating parts. But the laser welding is much more flexible. A laser beam can flow compactly past controlled by computer systems. This makes it suitable for complicated parts with the different shapes and designs. This is one reason why laser welding has become extremely important in industries such as the automotive manufacturing, electrics, and electrical vehicles. The third difference is speed and automation. Modern manufacturers require high-speed production. Laser welding has a major advantage here. It can work together with the robotic arms and automated production lines. A computer can control the lasers placed with extremely high accuracy. This allows manufacturers to produce thousands of the identical parts with consistent quality. This is especially important for electric vehicle production. Inside an EV battery pack, thousands of the connections must be made accurately and reliably. Laser welding powers the speed and precision required for this new generation of the manufacturing. However, laser welding is not perfect. It also has a challenge. First, it requires the high manufacturing precision. This gap between two parts must usually be controlled carefully. If the field of is poor, welding defects may appear. Second, some metals are difficult to weld with lasers. High reflective metals such as copper and aluminum can reflect laser energy, making the process more challenging. But with this development of the fiber lasers, better controlled system and advanced welding technologies, these challenges are continually being solved. So, when compare friction welding and laser welding, which technology is a winner? The answer depends on the applications. If you need a maximum strength for heavy-duty components, friction welding may be the best choice. If it is reliable, strong, and perfect for parts of the experience extreme mechanical strength. But if you need speed, precision, and automation, laser welding has a clear advantages. It is becoming one of the key technologies behind the smart factories and advanced manufacturing. The truth is, friction welding and laser welding are not enemies. They are two different tools designed for different problems. Friction welding respects the power of the mechanical force. Laser welding respects the power of the controlled lines. One brings the metals together through pressure and deformation. The other brings the metals together through precision energy control. Both technologies have to challenge the way humans manufacture products. And in the future, both will continue to play an important role in different industries. Well, that's all content I wanted to share with you today. Thank you very much for your watching this video. If you enjoyed the topic, please don't hesitate to subscribe to my channel and leave your thoughts in the comment section below. By the way, which welding technology do you think is more impressive? The power force of the frictional welding or the incredible precision of the laser welding? I would love to hear your opinions. See you next time. Bye.